Hey, this is Marty. Welcome to Kicking with Computer Science. Today we're going to continue the swing tutorial that we've been working on. Today we'll add a ball that moves from right to left and back, basically hits walls and bounces back and forth. We'll also update the buttons we added last time to control the starting of the game and pausing of the game. So as mentioned, first thing we're going to do is add a ball. So let's add the ball to our game panel. So ball B equals new ball. All right, so we've got a ball, but we haven't defined it yet. So let's go ahead, create a class ball, and we'll just pop it in our current package. So now we have a ball. Now we need to think about the behavior of the ball and what properties should be encapsulated by the ball. So ball is going to need a height and width. So we'll define width and we'll just give it 20 and height equals 20 as well. Normally a ball would have a radius, but the way the swing fill oval method works, it requires a height and width. So we'll go with that. Also, a ball needs a position on the screen. So in order to do that, we'll define a new class called position. So position P equals new position. Okay, so, oh, and we want to make these not pirates, but privates for encapsulation. Okay, so we've created a position. Again, we need to create the class position. And a position will just have an XY coordinate, int X, int Y, and we'll add getters and setters for X and Y. Make these private as well. And the other thing we want to do is add a constructor. So constructor using fields. There we go. All right, so we have a position, we have a ball, and so we define the position constructor with an X and Y, so there's no default constructor anymore. So we'll just do position P. And so also ball is going to take a constructor. So constructor using fields. Ball's not going to take any of those. A ball constructor will be an XY coordinate, int X, int Y, and comma int Y. This dot P equals new position, and we'll just pass in XY coordinates. Okay, so what else does a ball need? A ball, if we're thinking about object-oriented programming, the behavior of a ball is going to move, so we need a public void move method. And also, since we're talking about swing, ball needs to be able to render itself. So let's just create a render. And the render object or method is going to take the graphics object that we've talked about before. The graphics object, which we need to import. Graphics object is really the swing interface that allows you to draw objects onto the component. It's almost like a paintbrush, to use an analogy or metaphor. So let's render our ball. So we'll do g dot set color, and just make it a green ball just for fun. And g dot fill oval. That's going to take a width and a height and the x and a y from the position. So we'll do p dot get x and p dot get y. Okay, move will fill in a little bit later. So here we have our ball, and now in order to this is complaining because we don't have a default constructor, we have arguments, so I'm not sure why it says flags and flags. As we just did, we need to pass an XY coordinate. So we want the ball to start at the middle of the game. So we're going to define a class that holds constants called court. And the X coordinate, we want it to be the court width divided by 2. And we don't have a court, and we'll do court height divided by 2. All right. So let's create a class called court. And so we've got our court. And so now, since we added some constants, create a constant called width. And let's make that 700, I think, is what we did before. And create constant height. And we'll make that 500. Okay, so oops, we've got a court, got a position, and we've got the ball. So let's look at the game panel. So if we run this now, still don't have a ball on the screen. So what we need to do is call that render method. So we've got a ball render. We need to call that. So we'll call that from the game panel. I believe we created a paint component. And so let's go ahead and do this dot b dot render. And then we'll pass it. So at this point we have a ball. Ball doesn't do any type of moving, but now's a good time to point out exactly how this paint component is called. So if I add a calling paint, so if I add a system out call for calling paint, you can see that it's called once as this screen is rendered. But the interesting thing is this paint component is a callback. It's called by the swing interface when the screen needs to be repainted. So the system will automatically call back the paint component method that you've defined. So we could see that in action if we change the size of the screen. And if you see down here in the console, paint components call multiple times as we adjust the size of the screen. So what I want to show you is before calling render, we can make a new method called, actually we already defined it, move. So we'll call move before we call render. So if we go back to move, um, so when we render the ball, we're rendering at position X and Y that we've defined. So if we update the X position before we call render, then we should see the ball actually move on the screen. So let's just kind of demonstrate that. So we'll do int x equals p dot get x. So now we've got the X position. And so we can say x plus plus, which will increment it, and then we'll say p dot set it. All right, so now every time if we save the game panel, every time paint component's called, the ball will move one to the right, 1 pixel to the right, and then it'll be rendered. So let's see what happens here if we run it. So it doesn't move, but if we change the screen, you can see the ball is moving to the right very slowly. So that's generally how we're going to get the ball to move, but we don't want to have to change the size of the screen to get this ball to move. One thing let's do, let's actually make it move a little bit faster. So we kind of implicitly have defined a speed of 1 pixel per paint update. But if we were to do something like this, so every time we call move, we update it by 5. This would effectively be the speed. So let's define, we're going to refactor this 5. So we'll do a refactor extract constant. And we'll call this speed. All right, so now our ball is moving to the right at a speed of 5 pixels per screen update. Let's see what happens. So we should see it move faster. Okay, I think it is. It's kind of hard to tell. So what we want is to be able for this paint component to be called without having to move the screen. So how can we do that? Well, Swing conveniently has defined a timer that will trigger an action which we can use to get the ball to move each time the timer is invoked. So we'll define a timer in our game driver. Timer t equals new timer. When you define a timer, it wants a start interval and it wants actually something to listen to these timer events. So we've got our swing timer, and so this, let's call it timer t. Okay, so this needs to be, this is a reference to this class. So we can either cast this to action listener, but this class, which is a game driver, is not an action listener, so that wouldn't work at runtime. Or we can implement action listener. So we'll implement action listener. So now we need to add an action perform method to the game driver. So here's our action performed method. We'll just change this to action event. And so what we want to do is call repaint. So this dot game panel dot repaint. So essentially what's going to happen here, oh yeah, with the timer, it's important to actually start it. So we'll do, so now we have a timer event. The timer will invoke action performed on some type of interval per millisecond. I don't really know what. And the action performed event is going to essentially call the game panel repaint. If I click on it, you'll see repaint is a method in the J component or the component class, but repaint actually does a callback to paint component. So we don't call paint component directly. We call repaint, which then in turn will call the game panel's paint component. And this is called a callback method. Just one more point, inside this callback method, we have super.paintComponent. So that effectively acts as an eraser. So we'll erase current screen when we call the super method. And then we get a reference to this graphics object. Graphics object is kind of like a paintbrush, and now we're painting this new scene. And so what we're doing is setting up the court, and then we're moving and rendering the ball. So let's see what happens. And there you have it. Oops, we've lost our ball. So we have a ball now. It's not really exciting because it zoomed right off the screen. But what I wanted to do is have the start and quit button get involved and actually start moving the ball and freeze the ball when you click on these buttons. So let's go ahead and do that. First, we're going to get rid of this system out print line. So what we need is some type of status that defines, or state that defines our game state. So the game states could be initialized. So we'll create an enum called game state. And the states will be init, running, paused, and done, just to make up some states. All right, so we're just defining this within the game panel class because that's the only place we need it for now. So we've defined an enum. Now let's add a game state property. Game state equals, we'll just assign it to init when we're started. Okay, so I mentioned that we needed the the button listener to get the ball started. So show you how to do that now. So we'll grab this game state. So in the game panel, in this paint component that's getting called on the timer, we only want to move the ball if the game started. So if it's running, let's try that again. If game state dot equals game state, okay, that looks better. Then we move the ball. In fact, we don't even want to render it unless we're okay. So now we want the ability to update the game state. So in order to do that, we need to go back and look at our button listener class. Here's our button listener. So last time we added systemout.println if the button is clicked. What we need to do is update the game state. Unfortunately, this button listener doesn't have access to that state property we just defined. So we could fix that by just basically grabbing this and making a nested inner class. So we'll get rid of the public. And so when the action is performed, if the game is started, we'll just say game state equals game state running. All right. And then if the quit button, we don't actually want to quit, we want to just pause. So we'll call this paused. And then let's change this button. Not push, pause. So and I think let's rename this from quit button to pause button, and we'll change that. All right, so let's run this guy. So nothing on the screen, that's kind of what we wanted. If we hit start button, there's our button, or there's our ball. Let's do it again. Start, pause. Okay, so it goes away when we hit pause, it doesn't freeze. So how could we fix that? So if the game state is paused, where's my paint component? So the way we could fix that is by adding more to the game. I guess what we could do is just add a else if here for now. Else if so if it's paused, we'll just render it. Okay, so now we've frozen the ball. If we start it again, it'll keep going. All right, so that's looking pretty good. Now, what we may want to do is add an initialization, kind of a splash screen that says welcome to the user. So if we say game state equals in the initial state, which I think is init, so we want to give some type of welcome, and I'll work on that a little bit later. So let's go back to the ball, and it's moving. So we're moving the ball every time the render method gets called, but as we saw, the ball moves right off the screen. So we basically want it to move until it hits the right side of the court, and then we want it to bounce off the wall and go back in the other direction. So in order to do that, we need to add a condition to this move. So we've got the x coordinate, so we can say if x is greater than or equal to court dot width. So if it's greater than court dot width, then we could say instead of plus equals speed, we could say minus equals speed, and then we'll do an else. So we get the x if it's greater than or equal to the width, then we decrement, and if it's, well, see, that doesn't seem right. It seems like, well, let's just see what this will do. So we'll start the game, and it goes off and never comes back. One thing that I've noticed is that our court needs to be defined a little different in terms of its width. The frame that we created was width 500, but the console or the panel that goes on top of the frame is a little less than 700. So Where are we with the court? I think if we make it around 670, it'll work a little bit better. So let's go ahead and run it again. Start the game. Okay, so you can see the ball is kind of getting stuck right on the edge, and why is that? So if we go back and look at the logic that we just added for the move, if x is greater than or equal to the court, then we change its direction, or we change, we decrement the x position by speed, which is 5. And then if it's less, so the very first time it hits a wall, it's going to decrement the x coordinate by 5, but then the next time it's called, it's just going to add it back because it's now, x is now less than the court width. So this isn't quite right. So what we want to do is introduce 2 more variables. So we'll call it motion x. We'll just give that a 1 to start, and private motion y. We'll make that 0 since we're keeping. We have to define them as ints as well. So once we get the x, I think what we need to do, we're going to pull this back out and set it here. And we'll always do a plus equal speed times motion x. And then if the court, we'll just make this -1. So we're basically changing the motion to be -1 would make it go to the left, and a positive motion would make it go to the right. So we don't really need an else here. So when x is greater than the court width, we change a motion x to -1. It starts as 1. And then in order to change the x position, it's speed times motion x. So in this case, once it hits the right-hand side, it would be speed, which is set to, what did we set it to, 5, times motion x would be -1. So x is equal to x plus -5. So let's see what happens. All right, so we start it, it hits a wall, and it bounces back. All right, and then it goes off the left screen. So this should be pretty easy to solve now. So else if, if x is less than or equal to 0, which is the left-hand side x coordinate, then we'll just make it motion x equals 1. All right, so now we've got a ball that's bouncing from right to left and back again. And we can pause it by hitting the pause button, and then we can restart it. So I think that's pretty much what I wanted to accomplish. I also mentioned a splash screen at the beginning. We'll work on that next time, but for now that's it. Thanks for watching, and catch you next time on Kicking with Computer Science. Goodbye.